All right. Good. Hey everyone. How you all doing? Enjoying Ignite so far? Awesome. My name is Tony, and today I'm a Microsoft MVP for Developer Technologies. And today I will be exploring a bit of those tools and libraries that help us enhance our unit testing experience on .NET Core across multiple platforms. So before I continue, I'd like to give a bit of a background on why I think this topic is pretty important. I was having a chat with a friend a couple of weeks back, and we were just talking about all the different things that we enjoyed in the full .NET framework that hadn't yet made it over to .NET Core. And then we realized that as it stands now, when you make research about how to achieve certain things in .NET, a lot of times you get information about legacy stuff that is actually connected to the .NET framework as opposed to the .NET Core. So for example, consider a Ruby developer who would like to understand how to run unit tests. A lot of the information we have on the internet is always pertains to things like Visual Studio and a bunch of other Windows-specific things. So for a Ruby dev who all their life has used a MacBook, for example, that's like a very high barrier of entry for them, because then it's a lot harder to find out a lot of that information. So today I'm going to be touching on a bunch of different aspects of unit testing. I'm going to show us a bunch of different tools, and I'm going to sort of do a comparison between like the tools that you're used to as a seasoned .NET developer that are Windows only, and they are open source / free / cross-platform counterparts. Does that sound good? All right. So the very first thing, let's see. Okay, this isn't working. No, I'm just going to do this. Oh, it changed. Okay, I guess it's a bit slow. All right, so the very first thing I'm going to touch on is target frameworks. I'm guessing a lot of us here are .NET devs, right? Okay, so you're familiar with the big three. You're familiar with MS Test, NUnit, XUnit. So these test unit frameworks, luckily for us, these big three that we're used to in the former .NET framework age have been ported all over to .NET Core. So we get that, we're able to still get a lot of that, of the benefits of using a fully featured test framework. So there's a new entrance to this list, which is called Fixie. And Fixie, I think, is quite interesting, and you'll see why in a bit. So what I'm going to do here is that the next thing I'm going to show you is just, let's see, okay. It's just a very brief code sample of how to use XUnit. So I'm just going to be picking a single one from each section that we talk about. So this is pretty straightforward. You import XUnit, you have a fact, and then you just assert a specific stuff. Now, I want to show you Fixie. Fixie is kind of very interesting because unlike XUnit, NUnit, and MS Test, which prefer to have like configurations and attributes and stuff, Fixie is, sorry, this thing isn't very, okay. Fixie is a bit more on the lightweight side, and it's a lot more convention-based. So for those of us who prefer lightweight tools, those things that are not like, do not try to do everything at once, Fixie is one of those little things that really makes things interesting. So for example, Fixie doesn't make use of attributes. All you have to do is prepend your class names with tests, and Fixie finds it out, okay, that figures that, okay, that is a unit test. Fixie also doesn't come with assertion libraries, and we're going to move on to assertion libraries in a bit. But so with Fixie, you can use whatever assertion library you have there. So right here, I'm using Shouldly. Shouldly is a pretty fluent assertion library in .NET Core that sort of makes, it does two things. It makes your assertion code a bit more English-like, and then it makes any errors you might get they contain a bit more detail than you get from, say, using assert.equals in XUnit. So this is Fixie. I really suggest you all check it out because I think it's one of those really lightweight stuff that gets shoved under the carpet because we .NET devs are used to, stuff that does 100 things. So, check it out. And then we're going to move on to assertion libraries. So what are assertion libraries? We saw in the previous slides. I'm just going to go over to XUnit. You can see XUnit has an assert.equal. So typically, this is what assertion libraries tend to do. XUnit, like NUnit and MS Test, they contain a bunch of things. They contain their own assertion libraries. They contain their own test runners. They contain a bunch of other stuff. So in a situation where you prefer to use a different assertion library, you have options from these two guys. So Fluent Assertions and Shuley, they're both open source. They're all cross-platform. And they also give you a very fluent way to express certain assertions. So this is an example of Shuley. So you can see here that instead of the regular assert.equal or assert.contains, you can have, they work like extension methods to existing method calls. So you can call a calculator.add, and then you said the result of this should be 5. Or you can see a person.first name should be one of. So it makes things a bit more, it makes your code a bit more cleaner, a bit more maintainable. And also it's a lot more easier to understand because it tries to be as fluent as possible. So we're moving on to mocking frameworks. I'm pretty sure a lot of us here are familiar with mocking frameworks. These are some of the very popular ones. And so these guys, they existed in the full .NET framework, and they've all been ported over to .NET Core, and they all work cross-platform. So you've got Fake It Easy, we've got mock, we've got ensubstitute. Personally, I think mock seems to be the most popular. I'm not quite sure. But what mocking frameworks help us do is that they, I'll just show you a code sample. Come on. Okay, great. So you can see from this quick code sample, we can see a simple interface. We create a mock for that interface. We tell the mock object that, okay, when the getCount method is called, likely to return the number 23. And then we return the actual iFoo object by calling mock.object. Now with this particular foo object, you can pass it to any method that requires the iFoo interface as an argument. And whenever that method, which is typically always in the library you're testing, whenever that method calls the getCount, it's always going to return 23. So this way you can be sure to, it helps you basically put in certain things like, I'll call them constant return values. So you can always test out, you can always test out your APIs depending on whatever situation. Now there's a specific, there's a particular shortcoming from mocking libraries, and that is because C# is a statically typed language. So mocking libraries can only mock interfaces, they can only mock virtual methods, they cannot mock sealed classes, they cannot mock static methods or static classes. So that brings us to the next bit, which is called isolation frameworks. So isolation frameworks take mocking to to the next level, being that they let you mock things that that cannot be mocked in the general sense. So for example, mocking libraries, they leverage things like inheritance and stuff to extend a particular object. But with isolation frameworks, they go a bit deeper by talking to the underlying runtime to simulate or to cause sort of like detours. So when you try to call a method, instead of it calling that actual method, it goes to a particular mock method that you specify. So we did have a bunch of them in this space. You have Microsoft Fix, Just Mock, Type Mock Isolator, Smocks, and Pose. However, in this entire compatibility table, only Pose works cross-platform. So I'll show you a quick sample. So for example, datetime.now. Datetime.now is it's a static property, and we can see that it's very, in the general mocking sense, you cannot extend it. You cannot. It's not an interface. So what happens, or how pose works, for example, is that you specify a replacement method. So basically, you're saying whenever you call datetime.now, you like it to return this specific constant date. And then you have a sort of isolation, I like to call it an isolation chamber, so that whatever code is run within this block, so it could be you're calling a method that calls into another method, wherever in the call chain datetime.now is called, it will always return this specific date. You do not have to override any interface. You do not have to pass in any argument to whatever method. And then I'd say, so fake data generators. These guys are actually very important, especially when it comes to testing real-world data. They let you generate different kinds of data, from like names to addresses. So you have a bunch of them here. You see faker.net is only supported on Windows, even though it is free and open source. And then you have the rest, which is you have Bogus, Genfu, and AutoFixture. All these three are fully cross-platform. They're open source, and they're free to use. And then, yeah, so this is an example of Genfu. It's really quite straightforward. You say you have a class, right? Instead of having to figure out, like sample names to always keep using to create a new instance of this class, all you have to do is, using Genfu, you can just say, give me a new person, and then it automatically just generates data in these two properties without you having to do that manually. And then for example, you want a list of people. You can just say, give me a list of this person class, and by default, it will give you like 25, and you can always override how much you want. And then I think finally it's code coverage. So this has, I think this is a big deal. It lets you understand just how much of your actual production / development code is being covered by your unit tests. So initially we had, we do have a lot of code coverage tools, but a lot of them are tied to Windows or Visual Studio and the likes. So we do have, we have the regular VS Code coverage that comes with Visual Studio. As you can see, it's Windows only, it's not open source, it's not free, it doesn't run on the Mac and Linux. We have .cover from our friends at JetBrains. That is also Windows only. And then we have OpenCover, which for a long time was the only open source tool for measuring code coverage. However, due to its technical implementation, it only runs on Windows. However, it is open source. And then you have these three guys right here, which are all open source, all free, and fully cross-platform. So you have Coverlet, you have Alt Cover, and you have Mini Cover. So all these three get you code coverage on .NET Core across all platforms. So very quickly, I'm just going to show us a quick demo where I have some of all these things included in the single project. So I'm just going to switch over. Okay, so I'm just going to switch over to this real quick. So I have my source. I've got my source right here, and you can see it's just it's a very simple person class. I didn't want to go too overboard with it. So you can see here that we have a full name property that concatenates the first name and the last name with a space in between them. And okay, I think, let me see. Is that good? Awesome. All right. So there we go. You have I'm going to close this. Yeah. So you have a very simple person class. We can see, so this is going to be the object of our test, this specific property. So we can go over here. We're going to take a look at the test file. So I'm using NUnit. Sorry about that. So you can see here we want to test full name, and then we use genfoo right here to create a new person object. We don't really need to know what it created for us, but we know that it created stuff. And then we want to ensure that the full name property that we have is actually does the work it's meant to do. And then instead of using XUnit's own inbuilt assertion library, I brought in shouldly just so that you can see it in action. And then we have another one here that just generates a list of people. And then I say the people should all be, and I specify a predicate. So let me go ahead and run that. Oh, okay, I think I already have it here. Okay. So I'm going to go ahead and run the tests. All my tests are going to pass because, well, it's something pretty simple. So to just show you just how, why I'd always recommend using an assertion library, let's just make the test fail. So I'm just going to put this as a string literal. Oops. Let's see. So I'm going to run the test again. And then here we go. So you can see we had an error, and you can see just how much detail we get. You can see it tells us the indexes, it gives us the expected values. Let me increase this a bit. Let me see. This doesn't work. Oh, okay. I fixed it. So yeah, you can see a whole ton of information, because one thing that shouldly does, it uses your source code to generate really great error messages. So it's super easy for you to understand where the problem is. And then to finalize this demo, if you come over to I'm going to show the CS proj right here. So we bring in genfoo, shouldly, we've got XUnit and stuff. And then we bring in coverlet for our code coverage. So you can see this is our coverlet.ms build. This particular Nugget package integrates with the build, with your build pipeline. So if you come back here and run our tests again, let me fix the tests. So I'm going to fix the tests. And I'm going to run the test again, but this time I'm going to specify that I'd like to get code coverage. And then hitting enter does the regular build, and at the very end it generates a very simple ASCII table giving us line, branch, and method coverage. And then when you come in here, it has its own coverage JSON format. However, it supports multiple outputs from OpenCover to Cobertura to LCOV. So for people on Linux, you can just use GenHTML to generate like an HTML report from the output of the code coverage tool. And I would say that is about it. You can always get in touch with me on all these platforms. I'm basically Tornado everywhere. And, well, any questions? What? Yeah, sure. I'll find out where to upload it. I think it should be available from the app, but I'll confirm. Any other questions? Okay, then. Thank you all very much for coming, and I really appreciate it. Enjoy the rest of Ignite.